Supervised learning. Supervised learning is a type of machine learning algorithm which learns from historical labeled data and predicts future outcomes. The input training dataset includes both the input values, also referred as features, and the known output values, which are labels with the correct answers. In this example, the algorithm is given a set of training data with images of dogs, where the data is correctly labeled as dogs. You can then use supervised learning to generalize from these examples and predict how likely the image provided is a dog or not. Each machine learning algorithm has its own strengths and challenges. The strengths of supervised learning are simplicity and ease of design. However, labeling millions of new data takes time and can be a challenging task. Supervised learning algorithms are used to solve classification or regression problems. First, let's talk about one of the use cases, classification. Classification problems predicts which class or category the object belongs to. It is a process of sorting a given set of data into different classes. The output of classification are distinct values. Binary classification predicts one of the two possible outcomes. It predicts answers such as, is this email classified as a spam or not? Multi-class classification predicts one of multiple possible outcomes in problems. For example, is this movie a romantic comedy, documentary, or thriller? Some popular algorithms for classification include logistic regression, k-nearest neighbor, KNN, support vector machine, SVM, random forest, and naive Bayes. In contrast, regression problems predict a numeric value from continuous outcomes. The goal is to plot a best fit line, or a curve between the data. For example, you can use regression to predict, what price will this house sell for? Some popular algorithms for regression include linear regression, k-nearest neighbor KNN, support vector machine SVM, and random forest. However, there is no single learning algorithm that works best on all supervised learning problems. Supervised learning algorithms. Here are some of the algorithms used in supervised learning. K-nearest neighbor, KNN, classifies a data point based on similarity of the k-nearest neighbor. In this example, if we choose k equals 4, KNN finds the 4 nearest neighbors to the new data point. Since the new data point is closer to more apples, it belongs to the apple class. In terms of applications, KNN algorithm can be used for recommendation systems and search applications where you are finding similar items. Support vector machine, SVM. Support vector machine, SVM algorithm, creates a line or a hyperplane, which separates the data into classes in classification, or predicts a specific value in regression. It is a popular approach in research. Random forest. A random forest algorithm consists of many decision trees. The algorithm predicts by taking the average of the output from various trees. Some random forest algorithm applications include credit card fraud detection and disease prediction. Naive Bayes. Naive Bayes algorithm is based on applying Bayes' theorem, which calculates the probability the likelihood of an event A happening, given B happens. Common applications include text classification and spam filtering. Linear regression. Linear regression trains an algorithm to find a linear relationship between the input and output data. It predicts a numeric value within a continuous range. For example, linear regression can be used for weather forecasting, price estimation, and stock price prediction. Logistic regression. Logistic regression is used to predict one of the two possible outcomes, such as the likelihood of an event. For example, logistic regression algorithms can be used to predict election results, probabilities of a natural disaster, and other such events. Welcome to an overview of Amazon SageMaker. Amazon SageMaker is a fully managed service that provides developers and data scientists with the ability to collect and prepare, build, train, and deploy machine learning models quickly. Amazon SageMaker removes the heavy lifting from each step of the machine learning process to make it easier to develop high-quality models. Amazon SageMaker provides all of the components used for machine learning in a single toolset, so models get to production faster, with much less effort, and at a lower cost. Here are some of the benefits of using Amazon SageMaker. Make machine learning more accessible. With Amazon SageMaker, machine learning becomes more accessible, enabling people to innovate with ML through a choice of tools, an integrated IDE, and no-code visual interfaces. Prepare data at scale. With Amazon SageMaker, you can access, label, and process large amounts of structured data, like tabular data from spreadsheets, and unstructured data, like photos, video, and audio. Accelerate ML development. With Amazon SageMaker, you can reduce training time from hours to minutes with an optimized infrastructure, and you can boost productivity with purpose-built tools. Amazon SageMaker also enables you to automate and standardize MLOps practices across your organization, allowing you to train and deploy models at scale. Amazon SageMaker can be utilized for specific use cases as well. With Amazon SageMaker Canvas, business analysts can easily prepare data, train models, and generate predictions using a point-and-click interface. They can then share the results with data scientists and integrate them into common business intelligence tools. With Amazon SageMaker Studio Notebook, data scientists can access data from structured and unstructured data sources, improve productivity with purpose-built tools, and fully manage Jupyter notebooks with just a few clicks. And with Amazon SageMaker MLOps, software developers can build CI/CD pipelines to reduce model management overhead, automate ML workflows to accelerate data preparation and model building, training, and experiments. They can also monitor ML model quality by automatically detecting bias and drift, and automatically track code datasets and artifacts at each step of the ML lifecycle.